So today we're going to look at lesson 5 in this unit on exponential functions and logarithms. And we're going to look at how do we solve and work with exponential and logarithmic equations. So let's look at our objectives. The first is how do we solve an exponential equation? And then we can actually use those concepts in something called the base change formula that allows us to evaluate a logarithm of any base. Recall that on our calculator, it just does base 10. What if it's a different base? So we'll be able to handle that. And then the third is how do we solve logarithmic equations? All right, so let's look at exponential equations first. And here's the basic form, right? We've got some base raised to our variable x, and it may not just be x by itself up there in the exponent. It could have a coefficient, it could have a value added to it, and that's all equal to our value a. So what's our strategy for solving this? Well, we already have one strategy. Remember when we learned to evaluate a logarithm, we could write it in exponential form and then rewrite both sides with a common base. So if we can rewrite a and b using the same base, we can solve it. But if we can't do that, our strategy is to take the common logarithm of both sides. So let's look at an example. We have 7 to the 3x power equals 20. Clearly, there is not a common base between 7 and 20. So we're going to take the common log of both sides. So common log of 7 to the 3x equals common log of 20. Whatever we do to one side, we want to do to both sides. Now, why are we taking common log? We could do this with any base of log, but remember, our calculators can take common log of any number. So we'll be able to use that capability here as we get a little further. All right, so now we need to get our variable x out of the logarithm. And this is where we're going to use the power property. So we're going to move that whole exponent to the front, 3x. So that becomes our coefficient. So 3 times x times the log of 7 equals the log of 20. So now we have an equation that we just need to get x by itself. So we're going to do two things, right? We're going to divide both sides by 3, and we're going to divide both sides by log of 7. So now the rest really is just calculator work, right? We have x equals common log of 20 divided by 3 divided by a common log of 7. So use your calculator at this point. And when we work on these kinds of equations, we're going to write our answer out to 4 decimal places, round it to 4 places. So we'll show a few steps here. A common log of 20 is 1.3010. We're going to divide by 3 and then divide again by 0.8451. That's the common log of 7. So we put all that together in our calculator and we get our answer, 0.5132. Now, how could we check that? Well, let's put it back into the equation for x. Right? So we're going to have 7 raised to the 3rd power times our answer, 0.5132. So that works out to be 1.5397. Now, your calculator, remember, can take any base and raise it to any power. So we want to do that and see if we get something close to 20. And the answer is yes, we do. Okay. Now, it's not going to be exact because, remember, we rounded off our original answer to 4 decimal places. But if it's close, you can assume you have the right answer. All right, let's look at a couple more examples. 5 plus 3 to the x equals 52. Now, we want to take the log of both sides, but before we do that, we want to just get the base and the exponent by itself. So we need to isolate that and do that by subtracting 5 from both sides. So now we have 3 to the x equals 47. We can take common log of both sides. We're going to move that x to the front using the power property and then divide both sides by common log of 3. And the rest is calculator work. So there's our answer, 3.5046. All right. Let's do a couple more here. See if you can do these on your notes or on some scratch paper. All right, take common log of both sides, move 2x out of the exponent to the front using the power property. and then divide by both 2 and the common log of 6. Now be careful on your calculator, right? If you want to do 2 times log of 6, you got to put parentheses around that when you divide. The easiest thing that I like to do is just find common log of 21 and then divide by 2 and then divide again by common log of 6. So we get those values and our answer is 0.48496. All right, let's see if you can do this one. All right, so we're going to subtract 3 to isolate the base and the exponent. Now we can take common log of both sides, move the x to the front, and just divide by a common log of 12, and we get our answer. All right, one more practice here. So take common log of both sides. We're going to move the entire expression x plus 4 to the front as our coefficient. Notice I put parentheses around it. The first step is to divide by log 3, right? We're not going to divide by 4 because that's not a factor. It's x plus 4, but we can divide by log 3. So then we can subtract 4. So now we have a few steps to do on our calculator. So take the common log of 90, divide by common log of 3, and then subtract 4, and we get our answer, 0.0959. All right, now a base change formula is a way that we can evaluate a log of any base using our calculator. And what this formula tells us is the log of some base b of m is equivalent to the log of any base c of m divided by the log of that same base c of b, the original base. Okay, so we can pick any value for c. We might as well use common log, right, since that's what we have on our calculator. So here's a little better view, right, of where the m, what we're taking the log of, winds up, and where the original base b winds up. So we're going to use base 10. So let's look at some examples. So log base 3 of 15, right? It's 3 to what power gives us 15? Well, 3 squared would be 9, 3 cubed would be 27. So somewhere between 2 and 3. But let's see if we can figure this out. So we're going to use the base change formula. So we can rewrite this as common log of 15 divided by common log of 3. So now we can use our calculator. And when we put the math together, we get 2.465. So remember, we said it should be somewhere between 2 and 3. Let's see, if we wanted to check our result, let's take 3 and raise it to the 2.465 power, and we should get something very close to 15, and we do. All right, let's see if you can try one here. Here we go. We're going to rewrite it as common log of 8 divided by common log of 4. Use our calculator, and we get 1.5. Now, does that make sense? As we could also write that as 3 halves, right? So 4 to the 3 halves equals 8. So remember, to the 3 halves means we're going to take the square root and then cube it. So 4 square root is 2, 2 cubed is 8. All right, last part. How do we solve an exponential equation? Well, we did that, right, at the beginning of the lesson by taking the common log of both sides. Here's our example. To solve a logarithmic equation, we're going to go the other direction. We're going to rewrite as an exponential equation. So the basic strategy is whichever form we have, we're going to basically get it into the inverse form. If it's exponential, we take common log of both sides. If it's logarithmic, we're going to rewrite it as an exponential equation. Here's an example, right? Common log of 3x plus 1 equals 5. Common log, our base is 10, right? So it's 10 to the 5th. Remember, 5 is our exponent, equals 3x plus 1. And that is an equation that we can solve for x. All right, let's go through an example. So common log of 3x plus 1 equals 4. So we're going to rewrite this in exponential form. So 10 to the fourth is equal to 3x plus 1. Now let's just solve it, right? 10 to the fourth is 10,000. We're going to subtract 1 and then divide by 3. And we get our answer, x equals 3,333. Let's try another one. Now here, what's different is we have this coefficient of 8 out front. So we want to get the logarithm by itself before we rewrite it in exponential form. So let's do that. We'll divide both sides by 8. Now we get common log of x minus 4 equals 0.75, and we can rewrite that in exponential form. It's okay, 10 to the 0.75 power. We can do that on our calculator. Equals x minus 4. So when we take 10 and raise it to the 0.3 or 0.75 power, we get 5.6234. And now we just need to add 4 to both sides to get our final answer. All right, you see if you can do this one now yourself. So the log is by itself, so we can go ahead and write it in exponential form. Our base is 10, 10 to the fourth equals 2x minus 2. We're going to add 2 to both sides and then divide by 2, and we get 5,001 as our answer. Here's another one for you to try. Now notice this method works no matter what the base is. So here's an example with base 3. We can still write it in exponential form. So 3 to the fourth equals 3x plus 6. 3 to the fourth, right? 3 times 3 and then is 9. 9 times 9 is 81. We'll subtract 6, divide by 3, and we get our solution, x equals 25. All right, so that's it. We know how to now solve exponential equations. We can use something called the base change formula to evaluate any logarithm, no matter what its base, and still use our calculator. And we know how to solve logarithmic equations by rewriting them in exponential form. All right, that's it. Take a look at the assignment I posted for you in Google Classroom.